Hello and welcome back to NorCal 715. Today I've got this solder station hot air blower and it's a model 862D Plus. Picked it up on either eBay or Amazon. It's only $55 I think. It's a pretty nice little unit for the price, works really good. The only problem I have is it displays in Celsius and we over here use Fahrenheit in America. And so I'll just give you a quick look at it here. So here's the soldering temperature. You can adjust it all the way up to 480 degrees Celsius, which is 896 Fahrenheit. And I usually keep it right around 400, which is pretty close to 750 degrees Fahrenheit. You can see it's warming up right there. And it's also got a hot air blower. We'll take it off the hook. And it also shows you the temperature in Celsius. So I thought what I'd do is try to take this thing apart and see if I can figure out a way to convert it over to Fahrenheit. A lot of times the chipset that's in these will give you the option with the solder jumper of either Fahrenheit or Celsius. So let's tear into it and see what's in there. Alright, so I've got it open here. And from the back you can see there's a couple of, here's the display modules, a couple of 7-segment LED units there. There's also a some type of a microprocessor custom programmed, most likely. I'll do a little bit of research on that, see what it looks like. Couple little ICs, transistors on some heat sinks here, and of course a power transformer down here in the bottom. So I'm going to go ahead and pull this front board loose and see if I can determine the driver for the LED displays. Do a cross-reference and try to pull up a data sheet and see if I can find out what chip they're using and what options it has available. Alright, so I've got the thing all torn apart here. As you can see, I've got the board out of it. There's the LED display driver, and it's actually driven off just a simple clock and data line that goes back over here to this microprocessor on the back side of this board. And I can't find any data on the microprocessor, but I did actually find a pinout on it, but it's not doing me any good. I made some little notes as to what the inputs and output pins were doing here. And then I happened to notice that while this thing's together, I see this one connector right here that's got nothing plugged into it, and it is an input to this processor over here. And so I thought, well, I'm just going to go ahead and put a little jumper across it. And so I went ahead and I just turned the unit on. You can see it's displaying 100. I put the jumper across it and it goes immediately to 212 degrees, 260 now, because it's actually reading the temperature of the soldering iron. So anyhow, it's set at 100 degrees Celsius. So as soon as I turn it on, it shows 100. And with it jumpered, it shows 212. Anyhow, that is the Fahrenheit to Celsius conversion. I'll do the same thing on the hot air if you can see it down there. 212, remove it, 100 Celsius. So all I need to do is just put a little jumper across those two pins right here. Quite fun taking this apart. Had to take the transformer out of it and the circuit board completely loose to find out exactly what's going on with it. But I'll give you a little insight when I get it back together. So one of the things I like to do on any of my soldering stations is I want to unearth the tip. I don't want it referenced directly to earth. So what I'm going to do here is I'm going to add a 2.2 meg resistor or a 2.2 million ohm resistor in between both the hot air blower tip and earth and the soldering iron tip and earth, because sometimes I do have to work on equipment while it's live, and I really don't want to come in contact with something that's got a high potential in reference to earth and something that is grounded. So I want it to dissipate the static more than anything. So I've got a resistor there, 2.2 million ohms. I'm just going to put a little piece of tubing over it. We'll go ahead and add the next one as well. I'm just do a quick job of wrapping the leads around it here. Do a quick solder tack job on it. Doesn't have to look super pretty. I just want it to be floating so that if I do come in contact with, 160 volts rectified DC as reference to earth, that we're not going to have an issue. It's not going to be blowing stuff up down the road. And we'll use the hot air blower function of this to shrink itself once I get it all put together here and get the leads trimmed on the other resistor. There we go. Trim those babies down a little bit. All right, so get the hot air blower ready here. Plug her in. Try to get a little bit better focus for you guys. Hot air on, 212 degrees. So let's bring it up to about 400 degrees. Now, as soon as it's in the cradle right now. As soon as I take the hot air blower out of the cradle, and we'll turn the fan speed up to about 5, so it's warming up there. It says it's already warmed up. A little LED flashing is indicating that it's pulsing the heater on and off. So let's see what we can do in here. Try to get better focus again. There we go. Turn the fan on. I have the smallest tip on here right now for doing SMD. It's only about 3/16 of an inch. This is heavy duty heat shrink. I believe it has hot glue on the inside of it to keep it from ever wanting to come off. I'm just using it just to protect the wires so they don't come in contact with anything accidentally inside here. But it's shrinking it right up. It really is a handy little device to have. It really does work quite well for the price you pay for it. And I figure if it ever gives up, I'll just spend another 50 bucks and buy another one. So here I just hung it back up. Get refocused. So I just hung it back up. It's in the cooling down stage right now. It's going to cool down until it reaches about 100 degrees Celsius or 212 degrees. And then it'll shut the fan off. So the heater's off at the moment. The reason it's taken so long is because I had that very, very small tip on it, and it's really not moving much air. If I had the larger tip on it, it would cool down much faster. Anyhow, this is the 862D Plus. Now it does take the Hakko 900, either 900T or 900M tips. So that is handy that you can just go out and buy a good quality tip to replace the tips that come with the factory soldering iron that really aren't all that good. Anyhow, it definitely serves the purpose. Should be shutting off any second. There it goes. As soon as it hits 212 degrees, it's going to shut off. And we'll get it all buttoned back up. Get better focus. Get it all buttoned back up. Just let you take a look at everything here. So all I did is I just took a little solder blob and put it on this side of the board. I didn't have a connector. I didn't want to short across those pins and get that nylon smoke in there. It's not a good smell. Okay, so I've got it all back together here. I've got it plugged into the kilowatt. And we're currently looking at watts. 5 watts in standby. Everything is off. Let's look at VA 8.3 and power factor of 0.6. Not too terribly good. They could have incorporated an actual on-off switch to disconnect the power transformer. So I've got the tip off of the hot air blower right now. Now I read somewhere that this has a 600 watt heating element in it. So I'm going to just turn the hot air on. It's currently set at 212 degrees. Probably can't see that. Off and back on. So we'll go ahead and take it out and just let it warm up to 212. And we'll see what the watts are. 87 watts. It's already up to temperature. Fan's on high. Now I'm going to take the temperature and turn it up all the way, 900 degrees. 896 is what it shows on the display. It should be coming on there. 570 watts. I'd say that's pretty darn close to 600 as it claimed. Now we're up to nearly 600 watts. We're at 795 degrees at the moment, 800 degrees. And we should start stabilizing out here in just a second. You should see the wattage go down. There it goes. So let's turn the fan down. And without as much need to produce heat across those coils, it should heat up and the power should go down even more. Anyhow, I'm going to turn the heat back down to 0. Well, 212. Turn the fan up all the way. And as you can see, it's cooling off, 11.5 watts. 11.3. With the fan on low. About 7.5 watts. Next, we'll let that cool down. And we'll test the current consumption of the soldering iron itself after this shuts off. Just as a safety feature, it's still up to 375 degrees. Even if I turn this off, it will not shut the fan off until the temperature reaches 212 degrees. Now let's go ahead and turn the soldering iron up. We'll look at the display. So we'll turn it up to about 750 degrees. And it shows it's heating up at about 100 watts. And we're up to 480, 500 degrees right now. We're at 70 watts output. That's a considerable amount of power for such a small soldering iron. This thing is pretty small, actually. It's not too terribly large. It does get up temperature fairly quickly. 62 watts right now. Should start pulsing that little LED any second to show it's on and off. So we're maintaining about 35 watts approximately. So that's a pretty good amount of power for such a small soldering iron. Alright, let's let it cool down. Anyhow, hope you enjoyed this video on the 862D Plus hot air rework station with soldering iron, converting it from Celsius to Fahrenheit. If you enjoyed this video, please consider making a donation to my YouTube homepage with the PayPal donate button. Or you can go to paypal.me/NorCal715. Remember, with your help, we can keep these things out of the landfill and out of the recycle bin. Everybody have a great day, and thanks for watching. Bye-bye.